MDM4U, 2.3 sampling techniques. A population is all members of a group being studied, while a sample is a group of items or people selected from that population. So in a statistical study, there's some group that we're trying to investigate, and the population is all people who could be potentially surveyed, or all people who are a part of that group of interest. A sample is a selection from that group that is being used as a representation of that group. So our selection size can vary, and one thing that we need to be careful about is, does the sample reflect the characteristics of the population? So whatever the demographics are, or characteristics in the population, that should be represented proportionately in the sample. So we can make an inference based on our sample about the population based on the evidence we have within the sample. So any type of conclusion about that population. Example, identifying a population. Identify the population for each of the following questions. Whom do you plan to vote for in the next Ontario election? So the population is all people who could potentially be surveyed in this question, and the answer is going to look like all people in Ontario. So all eligible voters. What is your favorite type of baseball glove? So for this population, we wouldn't just be asking anyone, because not everyone knows their favorite type of baseball glove. I know Rawlings, maybe Spalding, but people who play baseball is a better indication that those people are who would be the target group or who's of interest. Now, it also mentions that whether we're talking about amateurs, so the common person who's purchasing from a store, or professionals, that matters depending on what you're trying to get out of the study. Do women prefer to wear ordinary glasses or contact lenses? So the population would be something along the lines of women that need corrective lenses. Now, assessing the sample. A small sample may be representative of a population if the characteristics of the sample are similar in proportion to the population. If the sample is not representative, it is biased, and the survey results are invalid. So what we're going to do is discuss multiple types of sampling techniques, each of which are trying to select a group that are representative of the population. So simple random sample. Each member of the population has an equal chance of being selected. So if we were to draw names of a population from a hat, say it was 20 people at a school assembly, everyone has an equally likely chance of being selected. This is a simple random sample. Equal chances being the characteristic. Now, notice this. The size of the population is not indicated, and that is not a numerical value or percentage of the population that needs to be sampled as far as what makes a good sized survey. So that is up to your discretion. There is no rule of thumb. But a systematic sample, every nth member of the population, select every nth member of the population by going through sequentially. So a sample of 250 is to be made from a list of 760,000 customers. So for this right here, we're going to use the formula interval is equal to population size divided by sample size. So if you divide the total number of customers divided by the sample size, that will tell you that we are going to look at every 3,040th person in this list. So every nth just means some number. It could be every fifth, every third person in a population. This was a much larger example. And again, I just want to state that these are all random sampling techniques. Stratified sample. The population is divided into subgroups based on characteristics, and a random sample is selected in proportion to its size in the population. So strata means attributes or characteristics of a population. So it's divided into subgroups based on some type of quality. Example, design a survey of music preferences of students that includes 25% of the population and represent each grade proportionately. So the total number of students is 880. The survey is going to include 25% of these students, so it's 220 participants in this survey, or the sample size. That being said, if we want to figure out how many students in each grade would need to be represented in the sample size of 220, if you recall the relative frequency, which establishes the percentage of the total for each subcategory for grade 9s. This is done by taking 255 divided by 880, and that is, as a decimal, 0.29. We can take the 0.29 times the number of votes, because that will give us 29% of the total number of votes. And therefore, that's 64 for this group, and the same strategy or technique is used for each of the different groups. Okay, so notice that the total here matches what we need. And sometimes we'll need to use rounding because we might end up with a portion of a person and we would round to the nearest whole. Some non-random sampling techniques. Cluster sampling. If certain groups are likely to be representative of the entire population, then a random selection of such subgroups can be used as a sample. Example, a fast food chain selects all employees at randomly selected locations. So, cluster, think of it as little groups. There are, for example, McDonald's all over Canada. If we were trying to find out information about working conditions for young workers, then we wouldn't have to have all of the members in the population surveyed. That would take too much time. We could take some of the locations and ask all of the employees. So the selection of those groups would be a handful of specific stores. Next, multi-stage sample. Multiple levels of random sampling are applied. If the population is students within a school board, then A, randomly selecting some schools within the board and randomly selecting some classes within each school. So this is good because we have multiple stages of these selections. We have the different schools, as well as not all of the information is coming from a particular school, which might have students with certain characteristics. So to get a general view, multi-stages are used, multiple stages. Voluntary response sample. The researcher invites members of a population to participate in a survey. Call-in shows, mail-in surveys, feedback surveys, suggestion boxes are all examples. But note that the results from the responses can be skewed because people who choose to respond are often not representative of the population. For example, if there was a suggestion box at a Wendy's, the entries are likely to be of people who have extreme views, or they were emotionally triggered enough to fill out a survey form about the quality of their meal. So, is that representative of all people? Typically, a lot of people are not going to vote, and we're going to learn about the different types of biases, but this is definitely one type of data collection or sampling technique that will lead to bias. Lastly, a convenience sample. A sample is selected because it is easily accessible. A researcher may gather data from a secondary source, such as a database like Statistics Canada, instead of conducting their own survey as a primary source. So this can also just be those people that are immediately available to you. For example, if I wanted to know if students are enjoying the online quizzes on D2L, I could survey just my own class because they are readily available to me versus having to ask all students and all different grade levels. This is just a quicker, easier way for me to conveniently grab that data.